This is a summary section for chapter 10. So what we're going to be looking at here is just a real quick overview of the 4 conic sections that we've already discussed in class. The first 2 pages is just simply a nice little help sheet that kind of puts everything in one place for all 4 of our conic sections. So it's kind of a pretty cool little concept there. So you might want to take a look at that. Let's go into the examples that we have here, where all you have to do is identify the conic section. So let's look at the directions. Identify the graph of each relation. Give an explanation as to why it's a circle, a parabola, an ellipse, or a hyperbola. One thing that I want to mention here is do this without getting the standard form of the equation. It's actually much simpler even than that. I'm also going to go out of order on these. So bear with me. I'm going to do part B first. First thing I want you to know is that that doesn't say V as in Vermont squared. That's a Y. Some of it's covered up. This one, when I look at this and I think about my standard equations, notice that I have an X term and I have 2 Y terms, and one of those Y terms is a squared Y term. So immediately my brain says, hey, parabolas are the only, they're the only conic section that has a single square. Everything else has squares on both the X's and the Y's. So this one has to be a parabola because there's only one variable that's being squared. If you drop down to part D, you'll notice the exact same thing has occurred. Only one of my variables is squared, so I know it has to be a parabola. Now, if we go back up to part A, the first thing I notice here is that my x squareds and my y squareds are not on the same side of the equal sign. So at the very least, you need to think about what that would look like if they are both on the same side. You don't necessarily have to rewrite it, but you have to at least think about it rewritten. And so if I rewrite this with both of my squared terms on the left side, one of 2 things is going to happen. I know that this is either going to be a circle or it's going to be an ellipse. And I'm going to settle on the ellipse. And the reason I'm going to settle on the ellipse, it's actually twofold, 2 reasons. Number 1, both of my squared terms are positive. Remember, the squared term, one squared term is a negative in hyperbola. But for the ellipse, both squared terms are positive. But then what makes this an ellipse and not a circle? Because in a circle, both squared terms are positive as well. And what makes it an ellipse and not a circle is the fact that the leading coefficients on my squared terms, are different. Okay, my leading coefficients are different. Jump down to part E. Once again, notice that my squared terms are both positive. So this is either going to be a circle or an ellipse. But if I take that a little further, my leading coefficients are different. So that's how I'm going to settle on it being an ellipse. Both of the squared terms are positive, but the leading coefficients are different. Now compare that to part F. Notice that both of my squared terms, once again, are positive. So this says it's either going to be an ellipse or a circle. But now my leading coefficients are the same. So we're going to say it's a circle. Both squared terms are positive, and the leading coefficients are exactly the same. I think there's one that I haven't done. Yeah, part C. In part C, you'll notice that my squared terms, one is pos and one is neg. So automatically, I know that this is going to be a hyperbola because one squared term is negative. And that's how you would identify your conic sections without having to actually find the standard form.